Welcome, dear participants of our e-learning course, to our second webinar. It's quite interesting today because we are going deep into practical aspects of sludge management, and I'm happy that our colleagues from Borda, who are responsible for the designing of the practical sites, are with us. This is Anas Abu Khalaf from Borda, and his colleague Ahmad. What is your last name?
Masoud.
Masoud.
Okay, Mr. Masoud is with us. Sorry. And I'm happy also to welcome my friend and colleague Mostafa Biat from Markov Publishers, who will act as a presenter, moderator, and facilitator for the discussion. As always, in the GoToWebinar control panel, you find the handouts. You find the two handouts shared by our colleagues from Borda. One is the presentation, PDF of the presentation, and also the treatment schedule they would like to share with us. Okay, after having said these words, I would like to pass over to my colleague Mostafa, who will take over for me. Mostafa, go ahead.
Thank you very much, Dirk. So, Bismillah ar-Rahman ar-Rahim. Dear participants, you are welcome to this second webinar for this course, which is dealing of sanitation technologies and wastewater sanitation technology, and the link with the climate change. It's very important topic. Our first webinar last Tuesday, we mainly make introduction, and we have experience shared by Hans Hartung from Namibia, and also Ismail Elbaz, who introduced the projects and the course in the framework of the GIZ cooperation in Jordan. This second webinar will be more technical and very important, and I think it's in the heart of the topic. So we'll have a real experience in Jordan, which will be presented by our colleagues from Borda, Anas Abu Khalaf and Ahmed Masoud, and which will be dealing of sludge management in Jordan. And as illustration project, they will present the case of Wadi Hassan. So now I think it's now we have almost 35 participants, and I think it will be very intensive and very comprehensive discussion, and I hope as at least last webinar. And now I will give over to our colleagues from Borda, Anas and Ahmed. Please, you start by introducing yourself, and then we go to the presentation. And I remind our participants that the presentation perhaps will be split in 3 parts, and in between you will have the opportunity to share your opinions and to give your questions. Anas and Ahmed, please, the floor is yours.
Hi everyone, thank you Mustafa, and welcome to this webinar. Firstly, let me introduce myself. My name is Ahmed Masoud, working with Borda as a regional project engineer, and my colleague is Anas Abu Khalaf, working as a design engineer. In 2 minutes, let me introduce Borda for you. Borda is a German non-governmental organization. Our headquarters based in Bremen, Germany. We have our regional office in Jordan, in Amman, covering West and Central Asia region, and operating in Jordan, Iraq, and Afghanistan. Borda in general works in the field of sanitation and wastewater treatment, implementing decentralized wastewater treatment system and fecal sludge management solutions in the region. Hello, let me go briefly through the outline. We will start with generally speaking about sanitation and sludge management in Jordan. Then Anas will explain Wadi Hassan wastewater treatment plant case study. Also, he will explain sludge drying reed bed technology. ending with comparison between the planted and unplanted sludge drying bed, and a conclusion. In Jordan, let's start. Around 67% of the households are connected to 34 wastewater treatment plants through a sewer network. Others have on-site treatment, septic tanks, which do not function in well conditions, which cause a lot of environmental harm and financial burden to people because of the desludging costs. The 34 treatment plants have different technology of treatments. Most of them have activated sludge process. Some of them have trickling filter, waste stabilization pond, and a sludge digester, like the one in Irbid City. For management point of view, we have to predict the future sludge production. If we're considering the daily rate sludge production per capita, which is around 0.53 kilogram per capita per day, considering the population growth, we would have around 158,000 kilogram per day of sludge by 2025. Here's the famous sludge management chain, starting from containment, emptying, transport, and treatment. The treatment plants in Jordan use various types of sludge drying technology, such as centrifugal sludge dewatering, belt press sludge, stabilization pond, and unplanted drying bed. The dried sludge is usually stored in the facility and then transported for disposal in landfills, such as Al-Ikader landfills in the north of Jordan. But for the liquid sludge, sometimes the driver of the truck discharges the waste into wadis or illegal dump sites, which affect the environment in a severe way and decrease the quality of soil. Plus, the opportunity of contaminate the groundwater bodies is really high. Knowing that, or we should mention also that the Jordan depends mostly on the groundwater as a drinking water resource. The treated sludge, usually by composting or the sludge that removed from the planted drying beds, can be used in agriculture, home gardening, landscaping, or any other agriculture purposes. Unfortunately, in Jordan, reusing the treated sludge is still not accepted due to several socio-cultural and political factors. However, in Jordan, we have a good example of reusing sludge for biogas energy generation. In the biggest wastewater treatment plant in Jordan, its name is As-Samra. It covers 90% of its energy demand by wastewater, hydropower, and biogas electricity generation. Moving to the national guidelines and the standards about sludge management in Jordan. According to law, Water Authority of Jordan, abbreviation with WAJ, has all responsibility and authority that's related to water and wastewater, which include operation and management, and also the product of the wastewater treatment plant. But unfortunately, that law does not include a clear description of sludge reuse and disposal. To cover that, we have a technical regulations with its name JS 1145. It exists and issued in 2006 on the uses of treated sludge and disposal. It regulates the entire cycle of sludge production to its reuse as a fertilizer, soil conditioner, or this final disposal to landfill. That regulation classifies the treated sludge into 3 categories based on the quality, as you can see on your screen. This table, there is a 3 classification. Class 1, it's used for, let's say, it's the highest quality of a treatment. It's usually used for fodder, for fruit tree farming, or for rangeland restoration. While if you are meat, class 2, it's only suitable for use for rangeland restoration. And if your treatment is taking you to class 3, then it's not suitable for neither point, but it should be landfilled. Despite the presence of this legislative framework to regulate the land application of biosolid, unfortunately, we have instructions were issued by the Ministry of Agriculture and Ministry of Environment, banning the production and use of organic fertilizer from material originating from treatment plants. Both authorities have overlapping responsibility and authority. when it comes to regulate the biosolid and reuse. On the other hand, Ministry of Agriculture encourage any academic or experimentals that provide a best solution for biosolid reuse. Now, this is a general brief about, this is the first session. And it was a general brief about the sanitation and sludge management in Jordan, starting from generation to the legal framework and regulations that govern this management. Yeah, I will hand over now to Mustafa.
So thank you very much, Ahmed, for this nice presentation. I'd say, even for me, who don't know very well Jordan, now I have a good idea. But I think all the participants, now we have 36 participants. Now I think it's a very nice reminder and presenting the framework in the Jordanian case. You have any comments, dear participants, or question or something to complete the picture presented by Ahmed? If it is okay, you know that you see the hand icon, you just click in it to ask the right to speak. Now we have 2 participants. We have first Razgar. Razgar, yeah. Please go direct to the topic. No too long comments. Just give your very quick question or comment. Please, Razgar.
Okay, thank you very much for allowing me to have a comment. The question is, I'm not sure if he covered the dry matter content when he was talking about the reuse standard, because I am aware about it was one of the issues in Jordan, but I don't know if it has been solved by the Ministry of Municipality or Ministry of Agriculture. So the question is, how is the standard regarding the dry matter content for sludge, for agriculture or for landscape?
The standard, as I mentioned, it's exists and it's governed the reuse of the sludge. But unfortunately, even if it exists, but there is an instruction from Ministry of Agriculture and Ministry of Environment to stop using it. So the overlapping of responsibility and authority is still not clear to this point. So the regulation exists, but it's not followed, or let's say there is a conflict and overlapping that's prevent from following these regulations. So far, reusing the sludge for agriculture is prevented from Ministry of Agriculture.
Okay, so I just forget to remind our participants to introduce themselves quickly for our for Ahmed and for Anas before asking. So Sayed Saleh or Salah.
I am Sayed Saleh from Ministry of Environment. I think about the standard is they use in this presentation is an old standard. Now we have a new standard. This standard that used in this lecture, it's in 2006. The old standard uses of treated sludge and sludge disposal. We have a new one in 2016. Uses of biosolid and sludge disposal. It's defined. We have 3 classes. Class 1 and class 2 only we can use as soil conditioner, not for as fertilizer. It's forbidden from Ministry of Environment and from Ministry of Agriculture to use it as fertilizer, and we change the standard until we have experiments. We make now experiment in some area to find to make test after 2 years, and we will after that we will change the class 1 as fertilizer. We can use it as fertilizer, but now in the new standard only we can use the first class and the second class as soil conditioner, and third class we can disposal it in the landfill. Understand?
Yeah. Thank you for clarifying these points. I just want to ask you if it's really published on the Jordanian Standards website or not yet.
From GISMO, from
Yeah,
Jordanian Standards and Metrology. You can find it. It's a new standard. It's number 1145 by 2016. Now, not 1145 by 2006. Okay, we have a new standard now. Okay.
Thank you.
Yes.
Thank you.
Okay.
I think, Ahmed, if you don't mind, I will take another question, and the others I will keep for the next series of questions. I will take Iyad, because not Ian. I don't. Abul Gharib. Sorry for if I pronounce the name not in the correct manner. Please, yeah, is it Ian or Layan? Please, Ian Abul Raghib, sorry. Yes, you can talk, please. Your mic is open. Diane?
Unfortunately, we cannot hear him. Just one remark and one question to the contribution from Sayed. If there is a new regulation, please send it to us because we will publish it to the web course. We have only the old documents you are talking about and Border was talking about, the old regulations from 2006. And if there are new papers, please send them to us and we will gladly publish it. Within tomorrow, they are online.
Yeah.
Okay, thank you, Dirk. Now, Ahmed Subh. Ahmed, please.
Yes. Hello. Hello, everybody.
Hello.
I just want to ask our participant, Sayed, could you please distinguish or tell us what is the difference between both uses of the sludge when you said it is allowed to be used as a soil conditioner but not fertilizer? So I cannot understand what the sense behind this, to use it as a soil conditioner but not as soil fertilizer.
Sure.
Okay, just looking. Ahmed, you can just, because I can't see you, can you just raise your hand because I have 37 participants. Yeah, now I can see you.
Yeah.
Very quickly, please, because our agenda is very. Sayed?
Okay, you can in this standard, new standard, you can use it only in rangelands. In rangelands, in some places that Ministry of Agriculture make some places to use it in the rangelands in desert. Not in every agricultural places. Not for fruits or anything. Only in rangelands. You know.
But in this case, excuse me, Mr. Mustafa, when you allow to use the sludge as a conditioner for the soil, so you can use it everywhere, yani in agriculture or other places. So I think there is a big, let's say, mistake in how the standard is, let's say, specified in terms of the terminologies. So it should be very clear why we should say that it is allowed to be used as soil conditioner, but not fertilizers. You should mention, or the standard should mention clearly, it should be used for something and not
It's
for
clearly in the standard. In the standard, it's clearly that it's only used in rangeland. I opened the standard.
For the first chapter. Wow.
Okay. 1 minute. 1 minute.
I think because we have.
Okay,
I think in the second round of the discussion, you can answer.
Maybe by email I will send you. Okay.
Because we should keep to our because at the same time I am moderator and timekeeper, and
Okay.
I am worrying about this. Sayed, take your time.
Okay. I will send this standard.
And in the second round of questions and opinion, we will give you the opportunity to explain more what is the difference between the new standards and the ones of 2006, and to make clear the confusion raised by Ahmed. Okay?
Okay.
You agree, Ahmed Masoud and Anas? Can we continue?
Yes. So now I'm here, Anas Al-Khalaf. I will discuss with you guys about the Wadi Hassan case study. So first of all, Wadi Hassan wastewater treatment plant is one of the 34 treatment plants in Jordan, and it's located near inside Erbil Governorate, northern of Jordan. So just a brief and a little bit about its history. It was constructed in 2001, and it is owned by Water Authority of Jordan and operated by the Yarmouk Water Company. Actually, the Yarmouk Water Company is responsible to operate most or all the wastewater treated plants in northern Jordan. And the total project value for the construction at that time, it was $7.5 million US. So this central treatment plant has a maximum hydraulic design flow capacity of 1,600 cubic meter per day and around 800 milligram per liter for the organic load BOD. And it can serve up to 24,000 inhabitants or persons. So this treatment facility is working actually for the last 17 years, and it looks still today in very good shape. So if you go like for the first time, you will think that it's newly constructed, and the operation there is going really well. And also they have a laboratory inside, so they can test the effluent on a daily basis or by daily or weekly basis as requested from the ministry. The treatment plant used to serve 3 nearby villages, it's Qitim, Naima, and Shatara, and 1 Palestinian refugee camp, which is called Shahid Mufti, Azmi al-Mufti. However, in the recent years, the treatment plant got really overloaded and over-designed. The hydraulic flow reached up to 1,900 in average cubic meter per day, which is around 300 cubic meter more than the design capacity. Also, the organic load BOD reached up to 1,250 milligram per liter in average, sometimes more, sometimes less, but that's the average, which affects the effluent characteristic for the treatment plant in a very negative way. At the moment, it stays within the standards, but it will not stay like this for a long time, at that moment. So the Yarmouk Water Company and the Water Authority of Jordan thought to upgrade the treatment plant to accept more 800 cubic meter per day. So in total, we are talking about 2,400 cubic meter per day. And this plan was already set long time to cover more people or more villages nearby Wadi Hassan area. But however, the solution looks very expensive at that moment and needs a lot of time to prepare studies, and get funds and etc. So they came up with another solution. And that solution was mentioned in March 2017. because at that time also the plant was really overloaded hydraulically and biologically. And this idea was also only to pump the wastewater from the refugee camp that we mentioned before, knowing that there's a pumping station in that refugee camp, and to divert the wastewater from that camp to another nearby treatment plant called Wadi Shallale, which will reduce the hydraulic load at Wadi Hassan at least by, let's say, 40%. And that's what actually happened. What was happened. Also in Wadi Shallale treatment plant, it is under design. And that means it gets less water than its capacity. Also, they have there a biogas digester, so they can benefit from the additive quantity of the wastewater. It's almost 700 cubic meter to produce gas and convert it to electricity. So just to sum up, what is the situation at the moment? In Wadi Hassan, we have an average inflow now within, let's say, 1,200 cubic meter per day for 2018 and 2017 after March, and BOD within 1,250 milligram per liter in average. And here's what you see, guys, is like how the Wadi Hassan looks like, the treatment plant. So now just a brief about the wastewater treatment process in Wadi Hassan. It's a normal treatment technology. It's activated sludge. As you know all, I guess, that in each wastewater treatment plant, there is a pre-treatment, primary treatment, and secondary treatment, tertiary treatment, and sometimes disinfection step. So here, as you see here in the flow chart, we have the pre-treatment, including mechanical screeners and grid chamber. And then the primary treatment start included 2 aeration tanks. And after that, the secondary treatment will take place. I will not go into details, just to mention, including 2 sedimentation tanks. And here in the secondary treatment, the outlet of the secondary treatment, like we have 2 outlets, as mentioned in this flow chart. The first path is for the sludge, which is transferred to the sludge thickener tank, or some people call it holding tanks. And from there, from the sludge thickener, the sludge will be distributed to the sludge drying beds, the existing ones. And the supernatant from the thickener and the leachate from the sludge drying beds will be pumped again to the primary treatment for treatment. And the second path, for sure, is the treated wastewater, which will flow to the existing polishing ponds that was mentioned here in this photo, these big 4s. These are the polishing ponds in Wadi Hassan. And after that, you know what's a polishing pond is just about to improve the hygienic quality, to remove the helminth eggs and the fecal coliforms. And after that, there is a chlorination step. And this chlorination step actually in Wadi Hassan is not working on regular basis. It depends on the testing results of the effluent. If it needs to be disinfected, they do. If not, they don't do, sorry. And after that, there is an open channel after the chlorination step, which is connected to the nearby university. It's called Jordan University of Science and Technology. It's one of the main universities in Jordan. And they got this channel was approved through an agreement between the Yarmouk Water Company and Jordanian University of Science and Technology to benefit from the treated wastewater for agricultural purposes. And there is a big lake in this university, and there's some ducks and birds. It's a very good view there, and they use that water from that lake. Yeah, it's a harvesting rainwater lake, and also it's mixed with the treated wastewater from Wadi Hassan treated plant, and they use that water for agricultural purposes. Moreover, they also pump the Yarmouk Water Company from Wadi Hassan some amount, let's say, from the treated wastewater to the attached farms of Wadi Hassan. Maybe they're selling it, I'm not sure. Also, they have some student project inside the Wadi Hassan to green the area and to bring like lemon, to grow lemon and other stuff. So after reducing the hydraulic load, which was the problem of Wadi Hassan, the main challenge that they face now is the sludge. Currently, they have around 16, oh, it is not around, it's 16 unplanted drying beds, or sludge drying beds in another term. The system and the technology is working properly during the summertime because of the hot climate. But in wintertime, according to the cold weather and rainy days, the sludge cannot be dried enough and needs to be transported in a liquid form and on daily basis via tankers to the nearby dump site, which is called Al-Akeda. So sometimes in the same day, they truck their liquid sludge like 3 or 4 times per day, and that's really costly. So that causes a high operational cost for your Yarmouk company, as well as an environmental threat, because Al-Akeda dump site situation is not clear maybe till today for me. They are working on building new cells at the moment because their own cells are mostly full. So from the perspective of Yarmouk company, they need to find a solution for their liquid sludge. Also, the transport of the dried sewage sludge is a labor and energy-intensive procedure, and therefore economically it is not sustainable at all. So improve the sludge treatment on site. The treatment plant will result in reduced financial burdens for the operators, which is the Yarmouk, as well as in reduced environmental pollution and associated health risks. So at the end here, our aim is just to implement an efficient, robust, easy to operate, and sustainable sludge treatment technology within the ECC project. So shall I, Mustafa, go into details of the sludge drying reed bed technology, or maybe you can open the discussion for it?
Sorry, just time to demute myself. Yeah, I think perhaps we can here have one stop and have some comments or questions, clarification questions about the case, and also giving the opportunity to say it to explain the standard to 2016 standards. Just you don't forget your poll questions.
Yes, I just wanted to say this. I wanted to remind you there are 3 poll questions at all.
Actually, we passed by 2 poll questions, but we can maybe at the end discuss with the participants these poll questions, because we already passed by 1 and now is another poll question. So it depends on you guys.
No, if you want just to introduce your poll questions now, your survey, and then we continue with the discussion.
No, at the end is better. All of them at the end.
Okay, fine.
So now, dear participants, it's your turn now to. First, perhaps we will give Sayed. Sayed, you have 1 minute.
Yep.
Not more. After 1 minute, I will demute it. You have 1 minute to explain what is the plus of the 2016 standards, and you clarify the question of fertilizer and conditioner asked by Ahmed. Please.
According to Agriculture Law number 13 for year 2015, the rangeland is the lands registered in the name of the treasury of the kingdom, and other lands of the state shall be less than 200 millimeter as al-Marai land, rangeland. In this rangeland, we can only use the biosolid. That's the biosolid. It's forbidden in this law, in agricultural law, to use it as fertilizer in other lands, in agricultural lands. Only in rangelands. It's less than 200 millimeter per year, al-Marai land or rangeland. Understand or not?
I think it's clear, and also I want to give a hand to Dad the best to, I think, have more explanation about this. Please, Dad.
Good evening. Do you hear me?
Yes.
Yes. Good evening, everyone. According to soil conditioner or soil fertilizer, the soil fertilizer could be evaluated to its content of nitrogen, phosphorus, and potassium. If its content is high and the application rate is enough, it could be used as a fertilizer. But if it is not, and it has a high percentage of organic matter, then it will improve the soil structure and the water storage capacity of soil. So it depends on the characteristics of the biosolids itself and on the application rate that would be added. The Ministry of Agriculture refused at all to use it as a fertilizer. They refuse to use biosolids as fertilizers or soil conditioners at all. Then after several negotiations, and they accept to use some areas as experimental areas for 3 years experiments, and the soil characteristics will be evaluated, the groundwater contaminants will be evaluated, and the plant therefore as rangelands will be evaluated also. And this will, the results or the acceptance of the ministry will depends on the results of these experiments in the south and north of Jordan, where they allocated certain areas for these experiments. Thank you.
Thank you very much, Ed. And now I think we have since the first round with Iyad. Iyad Sahauna.
Yes, thank you. My question is very quick.
Can you just introduce yourself, Iyad?
Yeah, I am Iyad Sahauna, working as a technical consultant for USAID funded project to improve water sector in Jordan. And my question is deep technical, which is regarding the planning of the growth in the sludge production or the waste production in the next couple of years. I know that there is a deep relation between water consumption growth and the wastewater production or the sludge outcome. But is there any factor taken into consideration regarding the planning of the growth ratio, like agriculture sector or the economic growth or something like that, or it's just depending on the water consumption and its relation with the wastewater? That's it.
Thank you. I think Anas and Ahmed, I recommend that you collect some questions, and I will give you the opportunity to talk before continuing the presentation. Now we go to the next participant, Dr. Noor Kharabsha.
Hello, everybody.
Hi.
Hello.
Could you hear me, please?
Yes, very clear.
Okay. Okay, good evening. My question may be not on sludge treatment, but on wastewater treatment process. On the last stage, which is chlorine disinfection, may I ask my question or not?
Yes, sure.
Yes, please.
Okay, thank you. I don't know if chlorination for disinfection purposes is beneficial, especially with high BOD from the effluent from like this wastewater treatment plant. And I think it's very common on the wastewater treatment plant in Jordan. Because as far as I know, in the German wastewater treatment plants, no chlorination chlorination process is applied. It's forbidden due to its carcinogenic effects. So what do you say about this topic?
If the question was to me or to Dirk.
Yeah, perhaps I just want to add on this, because when using chlorine for disinfection, you need to be sure about the suspension solids. The rate will need to be very, very low to have more efficient process.
That's why my question is. So yeah. I think, for example, here in Salt, where I live and work, it's nearby for the BAU University. They use chlorine for disinfection purposes, and the operator there told me one time that we have worries about this process because it could cause cancers, and that's why I'm just wondering about this point. Do you take this point in your consideration, or just you want to do it because it's a part of the progress?
I think perhaps Anas, you want to answer now, or?
Yes, I totally agree with Dr. Noor, because when we reuse the treated wastewater for agricultural purposes and not other purposes, yes, for sure, no need for the chlorine disinfection. It's 100% carcinogenic, and it harms even the plants in some places. But yeah, I 100% agree with you. But we didn't actually design what Hassan was from the government. And at the moment, actually, they don't use disinfection by chlorine. So they send the water directly after the polishing ponds to Just University or just Jordanian University of Science and Technology. So they don't use the disinfection unless the test results of the effluent requires to disinfect the water because of the high bacterial or viruses or whatever. So that's my answer, but I agree with you 100%.
Okay. We still have the question.
I'm sorry. Sorry. In Germany, they use sometimes chlorination, and I visited many wastewater treatment plants in Germany, and they use chlorination sometimes at the end stage. So maybe it was that mistaken information for you, but I saw it in my eyes. So they use it sometimes. Thanks.
No, I think chlorine is used very in different processes. Even in drinking water, we are still using chlorine in different parts of the world, and also for reuse for disinfection, we are using chlorine. Yeah. I think the matter is how to use the process. I think there are some precautions that should be followed.
The new they use the ultraviolet, but if they like make sure that there is no suspended solvents at the end stage, many treatment plants in the whole world they use ozone, not ozone, sorry, a UV instead of chlorination for wastewater treatment. I mean, not drinking water. They use UV, and I saw it. It works actually if we reuse it for agricultural purposes or landscaping.
I think any kind of disinfection process, you need to be sure that suspension is at a very low rate to be for efficiency purposes to be very high, to have a very high efficiency.
Yeah.
Can you just tackle the question of Iyad?
I'm sorry, maybe I thought that the question was internally, but if he could ask the question again.
Ahmed or Anas, you didn't got the question of. He was talking mainly about the huge level of. I'm just looking for Iyad. Iyad, can you just raise your hand? Iyad, I can see you because I have 37 participants and my screen is very small. Iyad, yes, Iyad, please.
Yes. My question is regarding the production of sludge. To predict in the planning and the investment management regarding the growth rate. I know that technically there is a relationship between the water consumption or the water demand in the future and the percentage of proposed sludge growth. But is there any factor non-technical regarding agriculture or land development or economic that consider in the preparation of the prediction growth rate or not? That's it.
I don't know. From my knowledge, sorry, I don't have the answer. But maybe if somebody from our colleagues in the government or GIZ could answer. But from my knowledge and my colleague, I guess we have no question for that. We have no answer for that.
Does any one of the participants have any comment on the question of Iyad, the relationship, or is there any correlation between the water consumption and the sludge production? I think it's obvious that it depends mainly on which kind of wastewater process treatment process are you using. For instance, for natural ponds or lagoons, it's not like activate sludge when you are producing sludge every day. Not each 2 years or 3 years. Okay, we will perhaps give the opportunity to Khalil. Khalil, please. Khalil, you can talk. Khalil Atiyat. Do you hear me, Khalil? Your mic is open. You can talk. Please, Khalil. Demute yourself. Now you can talk. No, sorry, we cannot hear you. Problem of mic. Yeah, perhaps we can have Hadi. Hadi.
Yes. Thank you. I'm Hadi Surush, and I work with Swedish Environmental Research Institute. I have a question about the water quality in your effluent after the desludging and after the solid removal. Could you help me know the COD and total nitrogen and phosphorus content in the wastewater after it leaves the plant?
You mean the standards for desludging?
No, you have to the water. I think you mean the water quality after
the treatment, water treatment, or sludge treatment.
After a sludge treatment.
Sludge treatment is it's there is a leachate collect. Oh, anyway, that's another issue. But it has to be like, for example, the sludge drying beds. When you put the sludge above it, and then the leachate will be like collected through drainage pipes, and it will be sent back to the inlet of the primary treatment. So it should meet the standards anyway. If I got your question right.
Yeah, and after treatment, when it is passed through the wetland, do you reach the qualities for releasing the water in the natural water bodies like lakes or rivers? Are the NNP low enough to prevent the eutrophication? Or
actually, maybe I need to clarify this in the next chapter, but I will just answer you in a brief way. There's two kinds of wetlands, let's say. There's one wetland is for sewage and another wetland for sludge. The ones for the sewage, maybe that's what you meant. If it's considered as a tertiary treatment. So you send the wastewater to this wetland vertically or horizontally, and it will percolate through the filter material and will be collected through the drainage pipes, and then you can reuse it in irrigation. So most probably what we got is within the Jordanian standards. It's accepted and for the irrigation purposes, only for the irrigation purpose, nothing else. And class A, I mean, when I'm talking about irrigation purposes. So the best, the strictest ones, let's say.
All right. Thank you.
Thank you, Hadi, for questions. I still have, I think, 4 or 5 participants asking to speak, but I need to continue with the presentation with sludge. With the sorry, with Anas and Ahmed. So today we are talking about sludge. Yeah. Please continue with the third part of the presentation. Then we will have, I think, very large discussion at the end of your presentation.
Okay, great.
Thank you, Ahmed and Anas.
No problem. Just to repeat what we said at the end, that our aim is to implement an efficient, robust, easy to operate, and sustainable sludge inside the wastewater treatment plant to avoid a lot of disadvantages that we will handle in next slides. So what we have to choose is sludge drying grid bed. This technology is known and implemented worldwide. It works perfectly, especially in hot climates, such as our region, MENA region, and Gulf area. It has proved that this technology has a much higher efficiency in this region than the cold regions or Europe in general, due to many reasons. Because in the sludge drying grid beds, it's mainly a consulted wetland and it's planted. So we have a high rate of evapotranspiration. We have also a faster microbial dismantling, and it has a longer period of vegetation. And for sure, faster and stronger growth of the plants or the reeds that we will talk about now. So mainly, what is the sludge drying grid bed? That's a planted, constructed wetland. As you know, we have planted and unplanted. In Wadi Hassan, it's unplanted, but what we are aiming to implement is a planted, constructed wetland. And the plants mainly, we pick reeds, some kinds of reeds like Phragmites australis or P. carca, or any other kind of plant that is efficient in this kind of treatment, which is sludge mineralization or dewatering. So this technology And in general, the constructed wetland is not limited for sludge or wastewater only. It can be used also for stormwater treatment, gray water, irrigation, pool, lagoons, or even sometimes in drinking water treatment. But in our case, in Wadi Hassan, it is designed to receive, store, and mineralize the sludge because it's considered as sludge mineralization technology. Like the accumulated sludge above these basins, which we'll talk about in a bit, it converts through the year into a soil-like substrate, not only to store the nutrients, but also it's the CO2, which gives the opportunity to various reuse options. So in the worst case scenario, these basins of the sludge drying reed beds, as mentioned here in this slide, can act as a mono storage of mineralized sludge at least, which makes the future reuse much probable than with the method of just dump it or dry the sludge into the landfills and maybe get rid of it here and there. So the process of the sludge drying reed bed is that the liquid sludge discharged on the filter horizontally. We can see here the picture. So from the left to the right, there's a sludge distributed through this pipe horizontally, and then the liquid sludge, it will be distributed in an even, let's say, distribution above the filter material, because it's liquidous. So some people like always asking, okay, if you like discharge the sludge in horizontal way, it will accumulate only on the left side or the right side. No, but because it's the liquidous, so it will distribute in an even way, let's say. And then the sludge and the waste leachate, let's say, will percolate through the filter to the bottom drain pipes. So if you can see here at the bottom, we have a drainage system, 2 pipes, one here and one there. It's more actually in the design, but just it's just like a picture shows the process. And moreover, there's a microbial and fungal decomposition of the organic matter and pollutants in the rooted substrate matrix. Also, there's absorption and filter process occurs at that time. Some also of the wastewater nitrogen is released out as a nitrogen gas, which could be considered a denitrification process. So the system utilizes natural microbial processes to transform the pollution in the wastewater and the sludge into gases, minerals, and humus. And through intermittent loading, it's not one patch, and not continuous, it's like patches of the sludge drying reed bed. A radical change of oxygen regime we can achieve, actually. We can achieve this change. And after water saturation by feeding with the distribution system, drainage network, as we said, at the bottom will collect the leachate, and it will pump back this leachate to the inlet of the existing primary treatment at that plant. There is a handout that was attached here, guys. If you can just open it just to check the process briefly. I will start in 3, 2, 1. So the first year, it's the commissioning of the sludge drying reed bed. So as you see here, we have the pipe from the left, and at the bottom we have the drainage pipes, and above the drainage pipes we have a filter material. Normally it's 2 layers, like 20% gravel and 80% sand at the top. And we have also a freeboard, maybe 1.5 to 2 meters above the filter material. So this is the first year we can grow the plants and start feeding the sludge. From the second year, which is the second part, to the 6th year, we start sludge loading phases. For example, in Wadi Hassan, we have 4 basins of sludge drying reed beds, and it will be fed by sludge from the sludge thickener tank, which is existed in the treatment plant, and it will be like in a regular basis. For example, the first basin will get like 3 days of sludge, and then the second one and third one. It depends as a designer recommends. And if you check here at the right side, there's a word said increase of dry matter content to 20 to 40%, from 20 to 40%, knowing that the dry matter content from the sludge thickener is around maximum, it reaches 3 to 4%. The third one, this period is a bit critical. We need to stop sending the sludge one by one. For example, the first basin, we stop sending the sludge there for 4 to 6 months to dry the sludge, to reach the sludge dry matter content to 50%. and then we start excavating it, as it's mentioned in the fourth line. And then after we excavate it, we go to the second basin and start feeding the first basin. If it's not clear, and I will mention it now, the fourth one, and after we excavate, around 97% of the sludge, which is not sludge now, it's mineralized sludge, which would use as a soil conditioner in later stage. And we also remove the reeds and everything, and we leave about 3% of the sludge there just to continue the microbial process. And then at the last stage, we need to regrow reeds or whatever plants there for another period, like for another 9 years or 10 years. So our system mainly, it will stay maybe hopefully for 12 years, and then it will start dislodging, but that is the case normally. And it's 1 by 1. So from the year 6 to the 9th year or the 10th year, it looks like this. So 1 by 1, 4 to 6 months, 4 to 6 months, 4 to 6 months, excavating and stop sludging. The last stage, as we said, we recommission the sludge loading to the next 9 years, as mentioned, and that's the process. So, and if we go through this, I guess, and everything went well, this system could be sustained for 100 years. So also the reedy plants grow through the overlaying organic solids on the surface and develop numerous roots and shoots into the substrate. This leads to a forced dewatering, drying, aeration, and mineralization of the organic solids. Let's talk here about the advantages, but in brief way, because my colleague will continue on this. It's a natural technology. It could also green the area, and it has also a very long storage period. So no need for dislodging, as we mentioned, maybe for 10 years, 12 years, 9 years. It depends on the load. And it also can handle large amount of sludge. I know it depends on the design and the flow, but it also could handle it. It needs very low maintenance compared to other dewatering technologies. And the sludge also, as my colleague mentioned, could be used in the later stage as a fertile soil, or sometimes it could be treated a bed for compost or whatever reuse could be we could do. What elements should be available to implement these technologies? Briefly, we need a large area to construct such a technology. For example, this here is about like 10,000 square meter to serve around 1,200 cubic meter per day. So it's very large area. Its capex is high to construct this, but when we compare it to the OPEX and also to other dewatering technologies, then it will look cheap in the long run. So it's one-time construction, and if the operator take care of it as required, then it will serve for a very, very long time. Also, as we mentioned earlier, hot climate is preferable. If there is a native reeds, that would be better. And what we have faced some problems, or our experts also on board have faced problems of the operating. So they always would like to hear that there is a responsible entity to operate this technology. It doesn't need to have as very skilled people. It's only like simple training, and it's easy to operate, so easy to do the preventive maintenance activities. And so, yeah, for example, what we have for O&M operation maintenance activities is like open and close the valves regularly as requested. It check the basins, it check the reeds situation, the colors, the water distribution by eye and visually. And for us, another one is to flush the drainage pipes from time to time, or to harvest or trim the yellow reeds or remove the dead leaves, and just to make sure that the system is working efficiently at the end stage. We can see here like one of these constructed wetland, how it looks like. For example, these reeds or plants is not that high. In hot climates like Jordan, maybe in 3 years or 2 years, the one reed could reach to 5 meters if it got fed from the wastewater. In more hot climates like Gulf area, it reached like 7 meters or 8 meters, the reed bed. So it looks really good. And yeah, so that's all from my side. And if you have to discuss, Mustafa, let me know. If not, let my colleague continue with the presentation of the last 2 slides. We have now only the comparison between the sludge drying reed beds and the unplanted unplanted drying beds. So let me know to continue or not.
Okay, thank you, Anas. Thank you very much. We'll just see if there is any clarification question from the participants.
Mm-hmm.
I have one from Angham Mansour. Angham, do you want to ask yourself, or I read what you have, what you wrote? Angham, if you want to talk, just you raise your hand. Otherwise, I can just read what you have sent. Okay, I will read. Okay, she will talk herself.
Okay.
Yes, please go on, Angham.
Hello, my name is Angham Mansour from Swiss Pump Company. I just wondering about the sand thickness in designing the STRB treatment process. It depends on what?
Actually, it's a percentage. As I told you, it depends. For example, I said it's 20% at the bottom gravel and 80% sand. So that's the recommended layers for sludge drawing reed bed. It could be also like any other material. It depends on the purpose, on the sludge characteristics. But for the Wadi Hassan case, like we have like 80%, 20%.
Yes.
It's a percentage. Actually, if you have like 1 meter, then 80 centi with 20 centi gravel. If you have 2 meter, 160, as it is.
So they need to consider all these parameters
Sure.
the sand thickness.
Yeah, but it depends also on the sludge characteristics.
Thank you.
So the design came up after we tested the sludge in many cases, and after drying for 3 days, after drying 6 days. So GIZ did a very detailed sludge character analysis and test. Then we get that design.
Okay, thank you.
You're welcome.
Thank you. Perhaps we have another clarification or question from Dr. Noor.
Hello again. I have actually, Dr. Mustafa, 2 questions.
Yes, please go on.
Okay, the first one is to Mr. Anas. So why did you decide to use SDRB but not SDB?
Actually,
the last part of the presentation, no, plus.
I got the question. Actually, that will come actually in the next slide. The comparison between the sludge drying reed bed and the sludge drying beds, which my colleague will talk in it in details. But mainly the planted gravel, let's say sludge, the planted wetland, most of the time in hot climates double the efficiency. It doubles the efficiency. That's why we go for the planted one.
Have you taken the climate change into your consideration when you decided to use SDRB?
Yes, but in indirect way. From my perspective, maybe my colleague has prepared this part, but from my perspective, it's a minor thing because we are trying just to store the sludge in one place for 12 years without leakages, without truck transportation, etc. And we are not sure actually if the trucks actually they discharge the sludge in the right way. We are not sure about the landfills and these cells if they are like overloaded or not, or if they leaks or not. So we are now make sure that no groundwater contamination will happen, no environmental pollution will happen if you do the sludge drying reed bed. And the most important point is that the desludging interval is between 9 to 12 years. So even it's not how can I say that? It's not open for the environment. The reeds helps a lot actually in reducing this emissions from the sludge drying reed bed. Also, the reeds have the transpiration. Let's say we have evapotranspiration through reeds. Nitrogen will, as we said, as I mentioned before, will get to the atmosphere, etc. And it's much better than just to dispose it directly to the air. That's from my perspective. But maybe my colleague has another answer, or it's okay.
Ahmed, we cannot hear you, Ahmed.
I just prefer to wait for the next couple of slides, which say about comparison between sludge drying reed beds and the normal drying beds.
I am afraid that we did not hear you very well. There is some kind of interference with your mic. And just check.
Can you hear me now?
Yeah, better now.
Yeah, هلا يعني in one way or another, just participant took us to compare to the comparison slide between the sludge drying reed beds and the normal drying beds. From let's say from climate change point or environmental impact and emissions, I will just repeat the point that my colleague mentioned about the storage time and the process of emptying and cleaning the beds. In the normal drying beds, it requires maybe by month or monthly basis to clean it with the excavator, with the heavy machinery things, which consume some fuel and cause a lot of emissions, which affect the climate change for sure. But in the sludge drying reed beds, no, the storage time is from 6 to 9 years. That's mean less excavation and heavy machinery works, less fuel consumptions, and less transportation as well to the dump site, which in somehow cause less emission for the gas and effects of on the climate change.
Okay. I think we can continue with the presentation. I think there are 2 more slides, I think, and Hadi and I think Razgar, please just keep your questions for 2 or for few minutes, and I will give you then the right to speak. Please, Ahmed.
Okay. This table is just a comparison between the sludge drying reed beds with the unimplanted reed beds, which is the current practice at Wadi Hassan. My colleague mentioned a lot of things about capex and opex. For example, capex for sludge drying reed beds is higher comparing to the normal drying beds, but in terms of operation cost, no, it's less than the drying beds. The environmental impact I mentioned now, with our technology, the planted reed beds, less emissions, less transportation, less fuel consumption for transportation and for cleaning comparing to the drying beds. In terms of others, let's say in the sludge drying reed beds, it's not noticeable at all. It might be noticeable, but on the site, no, it's something in green, something. You're really interesting in seeing that things. While comparing to the normal drying beds, it's really a miserable one. The knowledge needed both, for sure, we need the expert design and construction and supervision during construction. And during construction, yeah. Other point is at the sludge drying reed beds, we are providing a wildlife for birds. Snakes might be dangerous, but it can be solved easily with the fence. While the normal drying beds, the unplanted one, a lot of flies and mosquitoes. Landscaping from point of view of landscaping point of view, yeah, greening and natural view for the sludge drying reed beds comparing to the other one. Yeah, you can just go through the table if you have just more questions before ending this session. Yeah, I'm handing mic for you, Mustafa.
Just one moment, I am just muting myself. Yes, thank you, Ahmed. Thank you very much. We'll see if there are any questions from participants. I think there are mainly some written questions. I will try to read. So the first one is from the beginning. It began from Ahmed Sabh, who was raising the case of the standards, and he was asking about the limits. He just recommend
about the comparison. We can move to the conclusion if there's no question about the comparison.
Ahmed is talking about the classification of sludge. There is as soil conditioner or fertilizer, and he said that it's very important to identify and to have a clear limits and to avoid any misinterpretation of the standard, and the standard should be very clear. I just remind you that our colleague Sayed already shared the standard, the 2016 standards. If you don't have them, I think Dirk will upload in the course platform. We have another comment from Hadi. Hadi how do you make sure that there would be no leakage to the groundwater? What is the level of the groundwater in the area? So I think this is direct question to Wadi Hassan case study. Is there any groundwater in the area? What is the depth? Is there any risk of infiltration?
Maybe I have the information, but I don't memorize it at the moment. So maybe in 5 minutes after we finish this, I can send the answer to you directly. But it's in a feasibility study, and then I have to change to another laptop. But I maybe 90% I have the number, but I forgot it actually. But it's not that shallow. For sure, it's not that shallow.
Okay, and also we have Angham Mansour to back to her question about the thickness of the sand, and she said that this is a matter of the porosity.
Yes.
And perhaps she said that the thickness of the sand layer should take account of the porosity.
Sure, actually, there's a very specific specifications for the sand and for the gravel. It has to be double washed. For example, the sand and the pore size between 2 to 4 millimeter, and the gravel also, I didn't memorize the number, but it's larger for sure. And there is a specification for this kind of filter material, even if it's not sand, maybe if not something else. And every kind of material, there's a specification. All of that will be based on the sludge characteristics that will enter to the sludge drying reed bed. That's what I mean.
Yeah, and I think also our colleague Said Salah, he said, I think it's comment, and I think, but it's very long. I think it's a long text. I cannot read it unless you want to summarize. Please say it if you want to summarize in few words, because I cannot read it. It's too long. Or you can just send it to your colleagues by email or in the course platform.
Mustafa, moreover, that's the bottom of the treatment sludge drying reed bed. It will be for sure confined. Yeah, we use normally concrete or HDPE, so it will be sealed somehow. So there's no leakage for sure. And we make sure of that.
Yeah. Okay, thank you very much. So now we have I don't have any hand raised now. So perhaps you can go to your poll questions, Anas and Ahmed.
So here's some conclusion, and then we'll go for the poll question.
Okay, please. Hello. Hello, we cannot hear.
Can you hear me now?
Now, yeah, now clear.
Yeah, okay. Just to summarize what we present, me and my colleague Anas, as a conclusion also, currently, as you can see, most plants do not have adequate sludge dewatering facilities, especially in winter time. They are just transfer the liquid sludge to dump site, which cause a lot of environmental hazards to Al Equator or to Ain Ghazal. Sludge treatment is a high priority problem in Jordan, and we need to find a very fast solutions, especially with the current situations with the Syrian refugees, for sure considering the capital and OPEX. And the sludge drying reed beds has a high potential actually, comparing to the current practice, and we will implement it by 2019 in Wadi Hassan, doing just maybe a further analysis and the study to enhance our comparison with the current practices. Thank you.
Most of the further questions were sent to you by email. Actually, if I may open my email and check the questions. So maybe here. I'm not sure where is it. I sent it to you, to Dirk, actually. But
yes. Okay.
We have it here. We have it here.
Questions here. The 3 questions, and I can publish them if you want me to.
Yeah, sure.
One by one.
Yeah,
okay.
First, start with
Mustafa, go ahead.
Yeah, we can go the first with the first poll question. With the first survey.
First survey is from your knowledge, what are the current sludge management practices in Jordan? And our colleagues from Border gave 3 options, and participants are, as always, asked to give their opinion by clicking one of the 3 options.
Okay, from your knowledge, what is the situation now?
Anas, please mute your mic. Please, we can hear a lot of noise.
Did I forget someone with? No, I think no one. Okay, we have now. Please make your choice, dear participants, because now we have only 65 participants have already made the answers. If you don't know, we have not any other option. If you just click don't know, but if we have after 2 minutes, I think we can stop, and the others we just suppose they don't know. Oh, 20 seconds left. So 80% of participants already make their choices. 22 now. I think, Dirk, we can stop the survey now. So we have 15% they don't vote. We suppose that 15% they don't know, and we have 85 they already made their choices. And we have Anas and Ahmed. Do you see the results? Can you demute yourself, Ahmed and Anas?
No, we don't see it.
Yeah, you don't see the results. So we have 30, let's say 40%. They say reuse after treatment. 30% safely disposal, and other 30% unsafe disposal. So it's like 40, 30, 30.
40, 30, 30.
You have any comment on these results? Were you expecting those results? What is in your opinion the situation in Jordan?
It's varied actually. The reuse after treatment, as you can see here, as an expert, we're just also confused about the standards, and plus recently Ministry of Agriculture and Ministry of Environment just combined together, so they might have a new rules and new regulations. So yeah, it's expected for this percentage, because let's say if you go for urban areas away from cities, the practice and disposal is really in a miserable way. They're just disposed in an unsafe way. So I would say that it's expected, actually, to be honest, this percentage.
Yeah, let's just according also to my experience in different countries, either in the MENA region or in the African region, I think that Jordan is very advanced in this area. At least they have a clear standards, 2006 and 2016. And in other countries, I think different departments, different ministries, they just say sludge from wastewater treatment is not in our business, and each one is throwing the ball to another, and it's the responsibility of no one, and the situation is disastrous. It's I think, and I have visited Jordan many times. I think you are in the right track. Perhaps more will is needed from contributors to improve the situation, but I think compared to the area, I think you are in the right progress. This is my opinion. Any comments from the participants? we prepare the second floor of questions? So we go to the second part of questions.
The second question is on now. To think this practice is sustainable.
I mean here the sludge drying bed.
Yeah, the sludge drying bed.
The unplanted one.
You remember this part of the presentation of Anas and Ahmed?
Yeah, I could also go through it. It's here.
Okay, our participants are giving their answers. Now 66%. I think now we should have 100% answers because you have 3 options, yes or no, yes, but with modification.
Yes, and we can see a clear development. I think we can close the poll now just to save a bit time and share the results. We have a clear result, yes, but with modifications is the clear winner of the 3 options, because no answered only 8% and yes without any modification 35%. So almost 60% voted yes, but with modifications.
60%.
Almost 60%.
Oh, okay. And does anybody say yes?
Yeah.
Yes, 35%. And now 8%.
So if I may comment on this, that the sludge drying beds, the unplanted one, is sustainable but with modification. Or if we have the capacities, if we have the good money, if you are like a country with a lot of money, yes, it's sustainable. Because for sure, it should like the trucking, as we said, and but it's a robust system at the end. But also it works only in summer. So in winter it works, but with maybe 10% efficiency of its normal efficiency in summer because of the rain, because of the cold weather. That has to be considered. So from my perspective, it's sustainable only in very hot climates. Like it's the whole year. It's 30 degrees. It could be sustainable if you have like money and if you have a good capacities to deal with it. But if I would answer this, I would say no. No at all. If it gets back to me, it's not sustainable at all.
Thank you, Ahmed. And perhaps we have 3 minutes to go, and we go for the last set of questions.
Yes, and the question is saying, if you were a decision maker, would you go for sludge drying reed bed or sludge drying bed? It's very simple, 2 options with saying yes or no.
As a sludge drying bed or sludge drying reed bed? Job, yeah. Oh, yes or no? Maybe that was a mistake. So A is not yes. A is a sludge drying reed bed, and B is a sludge drying bed. Sorry, that was a type mistake.
What was clear that you sent to us, and it's also clear that participants give the answer as they give to. They're saying to this question, this is a feasible option either sludge drying reed bed or sludge drying bed with almost 90%. So we can close this and share the results. Almost 86% are saying yes, this is feasible option, and no are saying only 40%, 14%.
Yeah, I got it.
Okay.
Yeah, that's great.
I think before closing, perhaps we can take one last comment from Lina.
Yes, sure.
Lina, please demute your mic and you can talk.
Yes. Thank you, Mustafa. But I have just one thing I did not understand regarding the first question that raised about the situation with regard to disposal of sludge in Jordan. Is it in reality safe, the disposal, or not safe?
If I could answer, yeah. Most probably, especially where the people are not connecting, like we are talking about 33%, they are not connected to a sewer network. And they use normally cesspits, and in institutions like schools or stores, they use septic tanks, hospitals, etc. Yes, we have a problem there. It's not safely, not only disposal, it's not safely managed. For example, there's some cesspits, they are not sealed from the bottom, and then they didn't dislodge it at all. And the wastewater and sludge will percolate through or infiltrate through the soil to reach to the underground or groundwater, which we will drink in a later stage. And another perspective for septic tanks, big septic tanks, sometimes if we are in a hilly area, like there's a mountain and then it goes down with the same many people live there. So the top of the hill, if somebody has like septic tank and it overflows, it also goes to another neighbors and another neighbors. It will become like some diseases it will be occurs there, like Salmonella, Shigella. And for example, we have a case in Jordan Valley, and when we like see the hospital there, they have a lot of problems, even environmental wise. But for sure, yeah, for the safe disposal, it's not only the safe disposal, it's the whole containment or the management. After that, in these areas that need to be dislodged, and the people that they dislodge their own cesspits and septic tanks, the tankers or the driver of the truck, when he didn't go to the right place or the dump site, like the Al-Qaeda in north or Lajun in south or Ain Ghazal, so they don't really go because it's sometimes like 30 kilo, 50 kilometers far from the village or from the area. So he would go to the nearest spring or the nearest free space, and he will dislodge the whole tank there and then go home and sleep well. So that's one of the main problems actually, that we see it in our own eyes. And when you go especially to these arid regions or the regions that are not connected, you see it by your own eyes when the tanker just discharge the sludge or wastewater in the spring or in whatever. Some people also they go open the manholes, and they dislodge there in the manholes, and then it will be mixed with the sewer and it may be clogged and do some problems sometimes. So we have checked many issues and cases within the ministry, and that's what really happens. But the others, like 67%, which they are connected to sewer networks, yeah, and it's safely transported, let's say, to the treatment plant from my perspective. And after that, the reuse is the issue. If it's treated well, if it meets the standard, and it depends on many reasons. So, but mainly, yes, we have a problem of illegal discharge of the sludge, if that answered your question.
Thank you very much. Perhaps we can take one really very last comment from Razgar.
Yeah, so I did not introduce myself in the last time, so I'm Razgar, independent consultant at the UNDP projects. So my question goes, do the speaker think the incineration of sludge would be an option in Jordan for the future, maybe in the cement plant, or because one of the legislation in the Ministry of Municipality was they allow the wastewater treatment plant to dispose the sludge as long as it should reach the dry matter content should be not less than 90%. When it's 90%, this means it's a very good fuel for incineration. So what do the speakers think about incineration plant in Jordan?
So hi Rezga, and I think we are aiming from our perspective to have a low capex and opex solutions. As you know, like Jordan's one is not a rich country in money, so we are looking for the low capex. And from as far as I know, that the incineration is pretty good. So for sure, it's very efficient, but it needs a lot of capex. That's what I know. But if you know something else, just let me know. But from my knowledge, that I know it's high capex and opex for the incineration. So what do you think?
If I just give you a very quick experience that we have, that was here in Morocco, to use the sludge in the cement industry. The experience was really very interesting. It was the first that the cement industry can be one of the final user of the sludge, but the main problem is logistics. Logistics, I mean, first that you need to have a cement plant near your plant. That is not always the case. Otherwise, we have to transport the sludge, which will increase the operation cost. And the second problem is you have to storage the sludge, and we have the problem of place. You need very large place, and you have a problem of smell. That was the results of the experience led here in Morocco. Otherwise, it's perhaps we need other experiences to show how this solution is feasible. Thank you very much. I think unless Anas and Ahmed have any last comments regarding the content.
No, you said it well, as far as I know. Yeah, that was a very good comment from your side, Mustafa.
Okay, so thank you very much.
No, thank you all.
From Bourda, Anas Abu Khalaf and Ahmed Masoud for this very practical and very technical presentation, and also the presentation of the case study from Wadi Hassan. It was very constructive. Thank you very much for your explanation. Also, many thanks to our participants for their very high comments and contribution, which contribute too much and very much and intensively in the exchange of what is the main purpose of this course. Many thanks to Dirk, our colleague Dirk, who is managing all the technical part of the webinar. And see you next week. Last word, Anas and Ahmed.
Thank you very much for all for attendance, and you are welcome. And it was really interesting to meet you all. Thank you.
Okay, thank you all, you three, and especially to the participants. Just 2 words to our classroom. You can see all what is prepared there. Sludge drying reed beds in general, how they are constructed, and the part of the presentation held by our experts today is also published in Module 5, Sludge Drying Treatment in Jordan, example of Wadi Hassan. And also 1 word about what our colleague Sayed was talking about. You can see that the new standard operation he was talking about is already published here. This is one of the main senses and advantages of e-learning, that the classroom can be changed very easy. And you can see here and download here what he was talking about already now. Okay, thank you very much for your attendance, for your participation and the presentations. And I look forward to see you next week. Bye-bye.